Hi, everyone. I'm Osman, and I will be presenting you my job market paper. I hope you're excited about hearing about oil spills at 5 p.m. So we've had a very nice diversity of paper topics so far in the camp. We've talked about deforestation, afforestation. We talked about air pollution and health impacts. We've talked about water crises, floods, etc. But nobody has mentioned phytoplanktons, and I'm livid to hear that. But in all seriousness, marine ecosystems represent the other half of the global carbon storage, right? And they've generally flown under the radar of economic research. Phytoplankton in particular, which are these like microscopic organisms that do photosynthetic activity similar to plants and represent like the fundamentals of the marine food web. Once again, similar to plants. They represent 3 times more global carbon fixation than Amazon forests, which are considered the lungs of the planet. And in coastal areas, to be clear, 95 to 99% of carbon fixation comes from phytoplanktons. For ecology nerds, the definition of phytoplankton here also includes microalgae and cyanobacteria. So it's a fairly broad definition, which apparently ecologists care a lot about sometimes. So just to let you know. And oil spills in particular represent critical danger for both the phytoplanktons and by extension on obviously the fish life. So the immediate impacts we're usually able to see fairly starkly. I gave the 2 of the largest examples here, but there is a complete breakdown of the local ecosystem in the short term, but there are potential long-term considerations if these oil spills, even after the oil slicks are cleared up, even after the disaster efforts, were to leave some impacts that are not easily observable, right? There is some aspect of marine ecosystems that are much harder to understand in comparison to terrestrial areas where you don't immediately see the damage, right? When we think of ocean acidification, for example, we usually think of global sort of CO2-driven changes in the pH of the seas. But when we're talking about a human-driven injection of oils into the seas, we're also should be concerned about pH changes in that local area to a much greater degree, which will have immediate impacts on phytoplanktons, which will then have immediate impacts on the marine life. And once again, not to foreshadow some of the results that I'm going to show you, if they have long-term impacts, we're talking about accumulating damage that we've not been easily observing, right, in comparison to environmental damage on terrestrial land. And in this paper, that's kind of what I wanted to understand, to look at the environmental and, as an extension of that, the economic impacts of oil spills, particularly in the long term. So I look at 14 oil spills around the world that occurred between 2009 and 2011. And my full data set ranges from 1997 all the way to 2020. So I'm able to understand impacts on average about 10 years later. I use satellite imagery specifically for the dependent variables that we're going to get to. I use Copernicus's phytoplankton-based data set. And I try to actually look at the areas that are impacted by oil spills, which, as I will get to a little bit in the literature so far when it comes to impact evaluation, hasn't been done very well. And more importantly, we have causal estimation. So this is important. And specifically using synthetic difference and differences, as I will get to, is quite important in achieving like a convincing estimation identification strategy here. To just give you the headline results right out the gate as we before we go into the details, 10 years after an oil spill, I find that the carbon biomass of phytoplankton fall quite drastically by 26%. Chlorophyll alpha, which is the primary sort of photosynthetic sort of component of phytoplanktons, you can imagine it as the indicator of sort of flow of carbon, falls by 16%. and supportable fish biomass, which once again I will get to. This is my indicator of understanding the impact of oil spills on fish, marine life, decreases by 20%. So when I convert these damages into economic impacts, a single oil spill can reach $1.1 billion, which is when compared to the estimations of the, well, not the estimations, the legal compensations that are provided publicly, it's 8 times larger on average. And for small, please go ahead.
On that slight misspeak there,
Oh,
can you
sorry.
say something about, no, I want to lean into the misspeak, whether you can say something about the comparison of the estimations in the sense that some of the big oil spills have been the focus of the large kind of contingent valuation studies, and how those sorts of numbers compare to those estimates as well as to the kind of realized compensation.
Yeah, one important part of this paper, I wanted it to be so that I also compare my findings to contingent valuation surveys, for example. In my data set, the only one where there has been like an actual contingent valuation survey was Deepwater Horizon. And as I will go into the details of it, that is a much more complicated story, actually. Unfortunately, a lot of the times contingent valuation isn't even an option to conduct like novelly. As I will get to, one of the shortcomings of these types of surveys is that they are so expensive and time consuming that there has been methods like benefit transfer, which render them, in my opinion, even less appropriate to use in comparison to how
But it's not a comment on their appropriateness. I just wonder how they.
I just wanted to.
And one can't extrapolate from some of the earlier, the sort of Prince William Sound.
I'm sorry.
Some of the earlier spills where there were these big contingent valuation studies, one can't kind of extrapolate from implied.
Yeah, we can. I can do something once again called benefit transfer, but in my consideration, that is even less appropriate because of the assumptions that are needed to be made. I tried looking into them. You either have to make some gross assumptions about people's purchasing power, like having to equate the let's say purchasing power of people in the United States to somewhere in the global South, or you need much more detailed information, which is a bit problematic. But I will get to that a little bit more. And finally, there is a difference that I find between small spills and large spills, the definition of which that I will get to, where the small spills do not seem to show significant impact in the short or long term. Oh, go ahead.
Oh, sorry, I didn't mean to interrupt. I might have missed this because I went to the bathroom at the beginning, but how do you get from the phytoplankton and chlorophyll to the 1.1 billion? Is that?
Oh, I will get to that.
Okay.
Yeah. The conversion is the step after the immediate results. So in that sense, my contributions with this paper is firstly to provide a scalable, affordable, and in my opinion, more realistic way to reflect damages of oil spills. So previous methods, as I've just mentioned, generally rely on surveying, whether it is stated preferences driven methods such as continued valuation surveys, which for those who are not familiar, we are interested in that case, people's willingness to pay or willingness to avoid another spill of a similar magnitude that has occurred. Or there is a relatively more recent line of methods called equivalency analyses, so habitat equivalency or resource equivalency surveys, which are once again much more so focused on restorative costs rather than the actual damages. In either case, they are fairly anthropocentric in that we're not looking at the environment that is being damaged and trying to find out what that is worth. Instead, we're focusing a bit more on people's perception of what should be done going forward. I would argue my approach is both economically and time-wise, and in terms of its, the fact that I'm actually looking at the spills makes it a better alternative. And beyond that, based on the differential results that I find that the ecological damage function in regards to the impacts of these spills work differently depending on the size of the spill. In a future iteration of this paper, I would like to have, instead of just a small spill versus large spill, I would like it to be a much more, let's say, continuous function. that is dependent on the size of the spill. For the moment in this paper, we're only going to look at two differentiations. And finally, obviously, there is going to be quite a significant social, economic, and policy impacts when it comes to disaster response, when it comes to like the amount of money that has been paid out versus how much damage is still in this environment and what should be done going forward. Because even though I'm only looking at 14 spills here, there's been tens of thousands of oil spills. So if there is long-term impacts, we're talking about cumulative damages that are going on. And this is going to be an even stronger point as you look at the event studies. So the 14 oil spills, as you see, are scattered all over the world. Unfortunately, there isn't a very nice data set that includes all of the details about every single one of these oil spills. I will progressively introduce which types of information I needed in order to construct this novel data set of 14 oil spills, but it includes their spread, their estimated spill size, their legal compensations associated, etc. One outlier across these 14 spills where 7 of them are small spills and 7 of them are large spills. This is based on ITOPF's definition. We're gonna get to it in the next slide, basically. One outlier here is the Deepwater Horizon, not just because of the sheer size of the spill itself, which is 780,000 metric tons of estimated volume. It is considered to be even larger, but this is the, let's say, more official figure you will find in the studies. But another issue here is that before Deepwater Horizon, right, roughly 6 years prior to it, there was another major oil spill that happened literally 40 kilometers away from where Deepwater Horizon occurred, which is called the Taylor Energy oil spill. And that oil spill was never fixed. It was a pipeline leak that continues to this day. It's been leaking the whole time, which kind of breaks apart my identification strategy here. Prior to the treatment itself, there's already been quite a bit of, let's say, treatment from a different source. Please go ahead.
Yeah, how come nobody cares? Like it was like Deepwater Horizon was like all over the news all summer, and I've never even heard of this other one.
Yeah, exactly. Recently, there was, I believe, some regulation passed. To my understanding, it is because of local state-related politics of not wanting to touch what's going on there, because it is a pipeline leak that is very, very difficult to address, as I understand. And there has, unfortunately, I believe there's been some anecdotal environmental studies that show that it may not have an impact. Which is obvious.
In the ocean than Deepwater Horizon? Is
it is on the ground floor of the.
And that's considered less serious?
No, I, as I understand, there is enough anecdotal evidence of like mixed results that it led to a political sort of stalemate where what type of response that should be given versus not given. I believe in 2020, they've started doing some sort of slick removal methods going down into the pipeline itself, but to this day, it continues to leak. I believe it is less than 1,000 tons of metric oil currently observed, so it has been cleaned up a little bit.
Less than 1,000, like total over all the decades?
No. Currently present in the ocean right now. There has been more, but I mean, it's the Gulf of Mexico. It's going to go everywhere, so it's impossible to exactly know the extent, because it's also impossible to observe when the source is deep in the ocean floor in comparison to Deepwater Horizon, which is on the surface, right? So
is that why Deepwater Horizon was so famous? Because it was on the surface and it was like,
not to be conspiratorial, but I feel like these images made people a lot more concerned about what's going on. A lot of the times, the amount of attention paid to these oil spills is literally driven by how big of a ecological disaster you can paint them to be. And like I said, one of my main contentions is that when you can't see the impact, it is a lot harder to argue what is going on and that there is an important impact. But in the appendix of this paper, if you go to the current version of it, I do look into it, and I find that pre-trends simply make no sense because there has been prior to the treatment, there's positive impact, etc. So the outcome variables. If you have any questions about it, please ask. I will just give you a layman's breakdown of them. So Chlorophyll alpha is what plants use in order to capture carbon. It's the same with phytoplanktons. Chlorophyll alpha, you can consider as the flow variable of the capacity of their ability to take in carbon. And on the other side, we have the stock variable, which you can consider to be C phyto, I will call it C phyto, or phytoplankton biomass carbon, which represents the amount of carbon that these phytoplankton hold within themselves. Now, in a recent Nature Communications paper, Atkinson et al. 2024, this information has been used in order to convert the available resources for fish into fish biomass. This is a relatively complicated procedure that involves a term called a normalized biomass size spectra slope. If you want to get into it, we can. For the moment, I will skip over it and simply say, instead of, in order to understand the impact on fish, instead of this cat and mouse game of tracking the fish or using estimates of fish populations, I look at resources in a given marine ecosystem that allow fish to exist in the first place. So if the resources that fish use as their food decreases, I convert this, the scientists convert this into impact on fish themselves. This method has previously, like NBSS slopes, as I mentioned, has been previously used in environmental sciences literature quite frequently to understand marine disasters, particularly oil spills, because oil spills represent a unique danger, as I've mentioned, on phytoplankton, and phytoplankton represent the sort of the baseline of the marine food web. So there is a pretty direct correlation that carries you from changes in phytoplanktons to changes in fish biomass. It's not a direct conversion function. It's a bit more complicated than that, but ultimately it is doable if you replicate the author's methodology. Now, on top of that, I use a series of covariates from environmental variables to hydrological variables, looking at ocean currents to human factors in case they are relevant, because all of these spills occurred in coastal areas. So fishing hours or vessel frequency can come into play. Now, to actually give you a visual intuition of how the methodology works. This is only for one spill. I need to remind that in my estimation, I look at all small spills on one hand and then all large spills on the other hand. But just to give you an idea, based on one spill, we have a little island right here within the, I suppose you could call it a coast. We have a spill called MS Oliva. And my assumption here is that within 45 kilometers of this spill, there is a treated area. This 45 kilometers in the benchmark estimation, I relax these assumptions in the robustness checks, but this is driven by my personal sort of investigation into each one of these oil spills. And on average, they reach about 45 kilometers based on the slick and the spill distribution. So in the benchmark analysis, this 45 kilometer perimeter around the oil spill is considered the treated area. However, the indirect effects of oil spill can also be prevalent. In some anecdotal instances, I've seen this reach as far as 70 kilometers. To be sure, I exclude up to 100 kilometer perimeter of the spill in order to ensure SOTWA.
What happens to the oil? Doesn't it just float around? Where does the oil go if it doesn't stay in the 45?
Oh, I mean,
the floor of the ocean?
No, it is usually, it either disperses around, once again, usually within the 45, until it is cleared out. I have not seen an instance where the oil has managed to float so far away, hundreds of kilometers away, except for
physically removed? Or?
Yes, the oil, the disaster, in each one of these cases, there is a disaster response that removes the oil. Yeah, whether through chemical dispersants or other means. Yes.
The circle you just excluded, they consider somehow like propagation through the ecosystem around, or
I didn't hear the final part, but I think, oh, sorry, go ahead.
Ecosystem, that's what you consider when you consider the violation there.
I mean, what I'm trying to do is to make sure that all of my potential donor pool is unaffected by the treatment. because the perimeter even further outside of that is where I take all of my potential donors, right? So I'm basically trying to isolate the spill affected ecosystem from the surrounding area where no spill has occurred, but my expectation is that due to the geographical proximity, some convex combination of the characteristics of these areas will be able to represent a robust counterfactual for the treated area, which is the SDID assumption. Yeah.
Sorry, I'm not aware of this. So when there's an oil spill, does it happen from a stationary structure or is the structure moving, the MSO lift?
No, the oil spill occurs, I mean, in these cases, I cannot speak to every single one, is when the vessel sort of breaks apart, right? So for example, in the case of, I believe Bonga FPSO is one of the most clear examples. You can see it where initially the ship will fail, but it will drift apart until it breaks apart, which starts to leak the oil, and that's like the stationary area in which the spill has occurred. Now the oil still moves around, hence the perimeter initial that I'm using, but that's due to the ocean currents and everything. Yeah. Go ahead.
I wonder if there's like a model similar to pollution dispersal that allows you to simulate how far it goes, depending on wind speed, time, and
Yeah, there are some models that I've seen in that sense. I haven't used them yet. So far, the data required seems to be too complex, but I have been looking into it, which is one of the ways where I would like to, it's one of the ways I would like to use to expand my data set, because currently I'm only looking at 14 spills, which is not the easiest thing, but yeah, definitely. Please go ahead.
What is the biological mechanism that you think of in the sense that you're looking at long-term differences and so there are sea currents, and so I can easily believe that it's hard to degenerate, like to break down oil, but I would also expect that the spill of this year will be completely spread out 10 years later. So you need somehow a mechanism that connects to the soil, or that allows us to explain why this problem remains local. No?
I would understand that it could technically spill farther outside. That is very, very difficult to, I suppose, check the extent of which. In the moment, in this paper, it is true that I am assuming even 10 years later, the impact is somehow like located within the 45-kilometer perimeter. I think the best argument that I can make in regards to that one way or another is that in my robustness checks, I relax this assumption and use alternative radiuses. And as the radius gets bigger, you can see the impact going down, which I think is an indication that the broader, as we go farther and farther from the spill, the impact starts to get weaker and weaker that is observed, at least in the long term. So I think that gives me some amount of indication that the impact is still, concentrated in the original area. Now, that doesn't mean there is no impact outside of that, and it could still disperse around, but it is very difficult, especially after the oil slick is removed. So there is nothing to observe other than what I'm looking at. It's very difficult to argue one.
That is surprising, because the water that's in that 45 is not going to be the same water.
Sure, but
so if the oil's sinking and going onto plants and doing stuff like that, I have to believe that would have a long-term impact. If it's just the surface water, I can't believe.
I mean, well, that's the thing. I'm not necessarily arguing that the surface water does not go one way or another. It is going to be concentrated by definition in the local phytoplankton communities, right? That's the impact that I'm observing, which will be, specific to that coastal area. So that is some amount of stationarity there. Of course. Oh, sorry. Go ahead.
Maybe you can somehow in a robustness check look at deep versus undeep spills.
Oh, sure.
You somehow need this connection to the soil, I think, to argue that the sea current would not spread it out for 10 years, no? And then that could, if there is this link that undeep spills give bigger effects, then you're like reassured that actually there is this connection to
I do have information on bathymetry, like the depth of the seafloor. That would be useful in this case to include. And let me just. But yes, that's a great idea. Thank you.
I wonder if you have any information on like fish migratory behavior, both to motivate how big this cutoff should be, but also, I guess, if fish don't migrate that much, then when you kill off all the fish, it's going to take a long time for them to recover. Whereas if there's loads of fish movement, then you would kind of imagine that would be a reason why you wouldn't get very local effects, because just a bunch more fish, then it's fine.
Well, one of the issues, unfortunately, here is that fish do migrate quite significantly, which is why I tried to circumvent that problem by, when I look at the impact on fish, I'm much more so looking at the impact on resources available in that ecosystem for fish rather than the fish itself, because the fish will go everywhere. And the scientific evidence on their, in terms of their migratory patterns can be difficult to locate because, like, for example, this spill, MS Oliva spill that I'm talking about specifically, happened in the most remote island on the planet. So we know very, very little about what's going on here. I'm like, whenever I try to look into the problem of understanding fish behavior specifically, I run into this issue of like uncertainty of how to understand fish maybe at which point in time, because they can migrate quite significantly interannually, especially when I'm looking at long-term impacts.
But don't the fish also affect the presence of stuff for the fish to eat? Because if they're there, they eat the stuff.
I mean, sure.
So you can't isolate, you can't, I guess you couldn't just by looking at the availability of food say that you're ignoring, you can like put to one side.
Well, it's not that putting it to one side. The expectation here is that there is an equilibrium, and the disturbance to this equilibrium, by definition, like especially in comparison to the comparable control group, necessarily represents the impact of the oil spill. Whatever fish dynamics that might be going on there, it should function similarly in the counterfactual. But once again, it's a difficult question for me to answer as well. But I mean, I agree with you ultimately. So given that the characteristics of the spill, I will try to pick up the, oh my God, that is insane. Okay, so you see all of the relevant information here. The point to pay attention to here is that the treated areas see a far greater decrease in comparison to the untreated areas. Given that, I follow a fairly standard synthetic difference and differences strategy where the dependent variable is my outcome variable. You see the fixed effects. The SDID effect comes here through the unit and time weight specific weights. In the benchmark model, I use no covariates. Therefore, in the treated areas, as I said, are limited to 45 kilometers, and the untreated areas are 100 to 200. But once again, the overall, all of these assumptions I effectively play with, and they're all coastal spills, so they are all within 80 kilometers just by the nature of them. Initial impacts, as I mentioned, the small spills, I see no significant impact. In large spills, I see a 16% decrease in the chlorophyll alpha, 26% decrease in phytoplankton, and 20% decrease in the fish biomass. This is once again a conservative estimate because this is not a one-time thing. Usually there will be cascading effects, etc. But there is also an important biodiversity implication here because we're seeing a fundamental shift in the share of different species presence here. So this is the first time this type of an impact has been observed across 14 spills like around the world. When we look at the event studies, I know, I mean, you can see quite clearly that there is not just a significant impact, but there seems to be a degenerating impact. In this case, I'm looking at phytoplankton biomass here, but it is also the same for the other dependent variables as well. For small spills, I see no impact throughout the entire data set. We just see an increase in standard errors, which is to be expected. For the robustness checks, I use alternative resolutions, distances for donor pools, I introduce various covariates. I also run a Monte Carlo experiment in which I take out all of the treated area and reconduct my quasi-experimental setup exclusively within the control areas and find just to see if I find any significant spurious impact. All of them seem to fall in line fairly well. Monte Carlo only starts to falter a little bit when I randomly edge pixels are chosen where the donor pool is particularly constrained, which is, I think, to be expected. If you want to go into the details, I would love to, but we have seconds left. I look at two different dimensions of impact. One considers the climate crisis. This is not as important because these are highly localized events, but nevertheless, it can be measured in terms of the impact on phytoplankton. Carbon, similar to cost of carbon. If you think about it, ecological crisis, I look at the impact on fish by looking at the market prices of fish and seeing like how that changes. For each of the large spills, I find that the impacts can rise all the way up to $1.1 billion in the case of Xinjiang port spill. And the past compensations are not only uncorrelated to the size of the spill, but they are also like an order of magnitude smaller. And in terms of policy implications, we're talking about changes to disaster response policy. We're talking about considerations for considering oil spills, at least their cumulative damage, to be a potential climate hazard because of ocean acidification and everything that I've talked about. And there are ways in which I would like to expand this paper. This is my job market paper, obviously. Thank you.